Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at yet another work and energy problem. So let's just get straight into it. In the figure, a 700 kilogram crate is on a rough surface inclined at 30 degrees. A constant external force P is equal to 5,600 newtons is applied horizontally to the crate as the force pushes the crate a distance of 3 meters up the incline. The speed changes from 1.4 meters per second to 2.5 meters per second. How much work does gravity do on the crate during this process? Alright guys, so as long as you keep your formulas in mind during these problems, they should be pretty simple. So let's write out our work formula. Work is the force being applied times the distance it is being applied for times cosine theta. Our cosine theta is going to be, our theta rather, is going to be the angle formed between the direction the object is moving in and the direction the force is being applied. So, as we can see here, the object is moving in this direction, the force is acting in this direction as gravity always goes down. So our theta will be this angle right here. Now, we know that our force is simply the gravitational force. Gravitational force is mg. We know that our distance is the displacement, which is given here as 3 meters. And as we've discovered here, our cosine theta is the theta here. So let me erase this really quickly. We can see here that our angle is 30 degrees, but since we are not measuring it from the horizontal, we're measuring it from this line straight down. It'll be 30 degrees plus this 90-degree angle here. So 30 plus 90 will give us an angle of 120 degrees. So cosine 120 degrees will be our value here. From here, finally, we're just going to have to plug in our mass, 700 kilogram crate. We can assume gravity is just 10 meters per second squared. So 700 times 10 gives you 7,000 times 3 times cosine of 120. The cosine of 120, if we draw it on the unit circle, here I'm going to provide a rough unit circle. It's going to be here. Cosine is going to be the adjacent side over the hypotenuse, which will give you 1/2. Let's multiply these three out. 7,000 times 3 gives you 21,000. And multiply by that by 1/2, you get 10,500. And one small thing I forgot to mention, I just realized I made an error in this calculation. Cosine of 120 degrees is actually negative 1/2, meaning that our final answer will be negative 10,500 rather than positive 10,500. And if we take a look here, that's roughly D, so that's what the answer that we would have to go for in this problem. You guys might be wondering why the discrepancy of 200 joules is here, and that's simply due to the fact that the person writing this problem probably used a value of 9.8 meters per second squared for the gravitational constant. However, a gravitational constant of 10 is acceptable on the AP test for the FRQ portion, and you should be able to get full credit for that. But you do need to keep this in mind that they may use 9.8 or 9.81 on MCQs. So make sure that does not mess you up. And the reason that there is a negative here, you might be wondering how work can be negative. So if we take a look here, the block, when we consider its vertical movement, yes, it's moving to the right, but it's also moving upwards. And this is going to be our displacement. But as we can see, our force due to gravity is going downwards. So since work conceptually is just work times or force times distance, we can see that the distance is going to be negative and therefore there needs to be a negative to imply this in our final result. I hope this made sense, and make sure to tune in later for more physics tutorials on this channel.